Hi, welcome, Dr. Bell, and so glad to have you with us to talk about your exciting project that you're doing. My name's Kim Walk. I'm the head of research at the Robert Conadors Foundation. And as a proud partner of the DIPG Collaborate, we are absolutely thrilled to inform you that the Collaborate is happy to fund your grant. And
Oh,
this is to the
oh
total
wow.
of
Oh
100,000
wow.
US dollars, or in Australian dollars, 150,589 Australian dollars. So a
Wow.
very warm congratulations from us.
Thank you so much for you for sponsoring this research. It's really important work. I haven't actually been able to do any work on this since April, like since my initial preliminary studies, and it's really exciting work that needs funding to go forward. There's a lot of sophisticated sequencing and animal work, which obviously takes funds. So this is going to open the doors to getting that important research done.
Well, congratulations, Dr. Bell. This is the best part of what we do. My name is Eleni Milios. I'm the CEO of the Cure Starts Now in Australia, and also one of the collaborative members. So your reaction is everything that we work for year in, year out. And come the end of the year, after the hard work and raising that we do, it's just the best reaction we could have. We are super excited and super proud to fund your work and to hear that you will be able to take that pause button off and get back to the important work you do. And that means for us that we're one step closer to finding a cure for DIPG. So thank you for everything you do.
Okay, thanks. Thanks for saying that. Yeah.
Well, and I echo those sentiments as well. I'm Keith Deserick. I'm the one that we've communicated a few times with regards to your grant, and very excited to see this. Obviously, it's been supported by all the organizations of the DIPG Collaborative. Also within the Cure Starts Now. I mean, you're talking about probably 76 different entities worldwide that have come together and supported this, and that's because it's a good project. It's also very novel too, dealing with lactic acid, and something that we haven't really seen those patterns in some of the other research. And you note that lactic acid is common with the DIPG cells, and you note that if there's an ability to block it, it could help therapy such as CAR T. I wondered if you could talk a little bit about that and why that's relevant.
So this initial stage of the project is more getting the basics out of the way. So it's a little bit more boring stuff. First of all, we need to just realize or make more concrete data, realizing is lactic acid something that DIPG cells are dependent on, firstly, and understand the epigenetic comparisons of that. But when I first realized earlier this year, actually, that this type of epigenetic control with lactic acid, which obviously controls both how genes are expressed in DIPG cells, but also the immune response, I realized this is actually really huge. I do have to start small and tick all the bases and stuff like that. But what's exciting about this is scientists have known for more than a century that lactic acid is something to do with cancers generally. And other researchers have shown that there's something about DIPG with the H3K27M mutation, which particularly has a lot of lactic acid there, but they don't know why. But we know from, I think, decades old research that things like radio resistance and more recently immune response and immune therapies are affected by lactic acid too, though why it's unknown. So starting this work into looking at how lactic acid affects epigenetic control or the DNA changes and how that affects DIPG will also lead into other projects and hopefully inspire other researchers on all different cancers and to follow this up. I think, because I also work on neuroblastoma, but because DIPG specifically has a mutation on a lysine, I was thinking, wow, this could actually be why that mutation is part of that disease. So that's why I'm trying to focus in a bit on DIPG, because I think that's actually could be quite special this lysine interaction with the lactic acid. But I think this type of work has potential for all different cancers,